Stanford University.
Welcome to CS 193P. It's lecture 18, our final lecture of the quarter. It seems like it just began a couple days ago, but time flies. We've got a lot to cover today. We're going to talk about, we'll start by talking about unit testing, and then sort of from there flow into a little discussion on some weird and wild things you can do with Objective-C. We're going to talk about localization so that when you put your app up on the App Store, people all over the world can download it and use it in their native language. And then finally, we're going to answer some questions from the old CS193P mailbag / Twitter feed. So unless there are any random logistical questions about anything final project related, hope you're all doing well on your other classes and finals. And I know it's kind of a crazy time of year. But yeah, all right, we're good? All right, let's get going. So unit testing. It's a favorite topic of mine. Unit tests are tests that are designed to exercise specific areas of functionality in your code base, whether it's an application or a framework or whatever. The idea is that they're really thin, lightweight, small, have minimal external dependencies. So a type of test that might not qualify as a unit test is something that depends on some remote server or a big database that's up and running. You really want these things to be self-contained and not dependent on stuff outside themselves. And another really big key here is that they're run frequently during development. These aren't tests that you run once a month or even once a week. I mean, ideally, if your test harness is set up in such a way that it's really convenient to run tests, you can run them every time you build. And maybe if they run quickly enough, you don't even notice. It just happens as part of your build cycle. This helps you to catch certain types of problems very quickly upon introducing them to your code. So next question, who writes unit tests? A lot of people think, well, I'll write my code and I'll have someone else write these tests to go along with it. Ideally, you as the developer are going to be writing tests as you write the implementation. So as you're adding some new code to your app, maybe you think of, well, there's this test that would maybe help make sure that this thing actually works, rather than just writing some code and flinging it out there and seeing what happens. There's this idea of test-driven development, where, and this is I think of this as more of these are suggestions. These aren't religious guidelines about how you must do software development, but they can be helpful practices. The idea with test-driven development is that you write some tests first. So you think about, okay, I need to have this new method that does X, Y, and Z, and you write a method first that exercises X, Y, and Z, and makes sure that all the behavior that you're expecting is actually occurring. You haven't even written any real code yet on the implementation side. You then fill in the implementation. You keep running your tests until they pass, and then you sort of repeat from there. So it's kind of a sort of flipped upside down way of thinking about testing and writing your code. So worth considering. The idea with running unit tests, as I mentioned before, is that you want to automate them so you don't have to explicitly run the tests. Because as you know, just like anything else that you have to put on your to-do list and remember to do, something like running tests inevitably gets kicked to the back burner, you forget about it, and next thing you know, your tests haven't been run in months. So a lot of testing frameworks let you run the tests every time you build. This is a really, really huge win. And you can think of it just as building your project, the compiler will check the syntax and make sure that you're not missing a semicolon or a square bracket or whatever. It goes, hey, something's wrong when you make a syntactical error. Unit tests ideally help check the semantics of your code. So if you've accidentally left out some line of code, some crucial line of code that breaks this really important method, hopefully when you build, your development environment will say to you, hey, something's wrong, fix it. So that can be very useful. Talking a little bit about the motivations and the goals for unit testing. This might sound a little bit like me, preaching to you, but hopefully it's not too obnoxious. One of the goals, obviously, is to have fewer bugs in your code. If you cover your code with tests, you can have more confidence that you're shipping something that doesn't have a bunch of holes in it and isn't horribly broken. So that's always a good thing. You can sleep better at night because you're not worrying about some edge case that you forgot to run through manually in your app before you shipped it out to users. Another advantage, sort of related, is finding bugs earlier. There's this idea that if you find a bug very, very early in your development cycle, the cost to fix it is low because you're probably thinking about that code. You're you're maybe working close to that code, rather than at the very end of your development cycle where everything else is locked down. You haven't looked at this class in however many months, and you're trying to remember, oh, what was I thinking when I wrote this? Who even wrote this? And you realize it's code that you wrote. You just forgot about it. So finding bugs early is a big win as well. Avoiding regressions. This really comes into play when you've got a big code base that maybe multiple people are working on. Maybe the code has been around for a long time. The Mail app on the iPhone has code in it that was written in the 1990s. That was from the desktop version of Mail. And sometimes you don't necessarily know what the dependencies are with a certain bit of code. And it can really help to have a test that will, if you make some unrelated change, and that breaks some other class that you don't even know anything about, for that to fail loudly and say, hey, you might have accidentally broken something that you weren't aware of. That's pretty valuable as well. A couple more things. Documentation, obviously, you can comment your code, you can write up a little spec to go along with it, you can document your code in a lot of different ways. Tests are another way of documenting your code. So if you're wondering how is this method supposed to be used, you can, ideally if there's a test for it, you can go look at that test, and maybe that is a good example of how this code is intended to be used. Finally, testing, I find that it encourages good design. Good design is kind of a fuzzy thing, but really what I'm talking about here is test with a lot that avoids unnecessary dependencies. A lot of times you'll try to write some tests for some code, and you'll find, man, like this code depends on all these other things, all these other classes, all these other objects being up and running and in this particular state in order to be testable. And what that probably indicates is that you maybe have some dependencies that shouldn't be there. They're probably complicating your code. They're increasing the probability that there are bugs. And thinking about testing and testability as you're designing classes can be a really helpful way to encourage good design in your code. Any questions about this stuff so far? I know it's pretty abstract at this point. Testing, yeah, it's great. Whatever, you're sitting there. So let's let's get into some specifics. There is a family of sort of similar unit testing frameworks. You'll find a lot of them have unit in the name. There is JUnit. Has anyone here used JUnit before? A few people. Okay, cool. NUnit for C#, PyUnit. There's all these other unit testing frameworks. For Objective-C, we have OCUnit, which confusingly, it's referred to as OCUnit as a product, but the framework that you'll find on your Mac, whether you're doing Mac or iPhone testing, the name of the framework is Sen Testing Kit, S-E-N Testing Kit. So if you see Sen Testing Kit, that's OCUnit. It's part of our developer tools. It integrates with Xcode, and it's part of the iPhone SDK as of version 2.2. So how does OCUnit work? There's a class that's a starting point for your tests. It's called Sen Test Case, and it's sort of an abstract test case superclass. And what you'll do is you'll create subclasses of Sen Test Case and then fill in some test methods with your tests. And what it does, kind of interestingly, and we're going to talk about this more later, it automatically runs any methods in it that begin with the word test. So to add a new test, let's say you've already got a subclass of Sen Testing Kit. All you do is add a method, call it test, foo, whatever, and the next time you run your tests, that new test will be included. And then there are some macros that are part of OCUnit for asserting various things. You can, if you want to make sure that something is not nil, maybe you're expecting an object back from a method, and you want to make sure that it's not nil in this case. You can say st_assert not nil, and you pass it some object, and you can pass an optional logging method to sort of give you a better idea of what happened when you're looking at the test output. Look in sentestcase.h and you can see the full list of testing macros. But the interesting thing here is that when one of these macros fails, it'll show up in your build log in Xcode just like a build failure, which comes back to the whole testing syntax, testing semantics. It's pretty convenient to have this stuff just sort of show up in your regular programming workflow. Then there's also these setup and teardown methods that are defined on send test case, where you can fill in some code. Maybe you want to have some code run before and after every test case. So this is true in other testing frameworks as well. It's a convenient place to put, if there's some object that you want to test in a bunch of different tests, you can put in your code to create the object and then destroy it, release it after every test is done. That way, every test has a fresh object that's uncorrupted from previous tests. So let's look at defining a new test case class. So we're going to import sendTestingKit, the sendTestingKit.h header. That's the sort of umbrella header starting point. There's some class foo, which we're forward declaring here because we don't want the compiler to say, hey, I don't know what foo is. And then the key here is that we're subclassing sendTestCase. We're creating our own class called foo_tests. It's got an instance variable called foo. This is all standard Objective-C stuff. So that's what the header looks like. And then in the implementation, so here's our implementation of foo tests. And maybe in our setup and teardown methods, maybe for every method, we want that foo instance variable to have some object. Who knows what this thing is? But it's a class that we want to test. So in our setup method, we'll initialize the instance variable, alloc init a new foo. And in the teardown, we'll release it so that it gets cleaned up and goes away. So we've got setup and teardown. And now we want to implement some tests. So here's our first method. Probably the simplest test case, the simplest test you can write is just making sure that this thing you've tried to create is not nil. So here's our test create foo. Notice it begins with the word test. When we say stassert not nil foo. And if that fails, in our build log, it'll say couldn't create foo. And we got this other method. Let's say that foo has a property called bar. We want to set the bar property and make sure that that actually worked. This is very, very contrived. These types of setter methods are very, very rarely fail, but I'm just illustrating the types of things that you might want to test. Here we make sure that these objects are equal. And what actually happens, stassert equal objects, it's not comparing pointer equality. It's actually calling the isEqual method on these two objects to make sure that they're functionally equivalent. That way, for something like strings, where maybe you've copied a string and you want to make sure that the strings have the same contents, but they don't necessarily have to be the same exact pointer instance. So here are a couple of very simple tests. Another really important thing to think about, rather than just testing positive conditions, is testing negative conditions or error cases, and making sure that your error cases fail in the way that you expect them to fail. So here's maybe foo has this bar at index method, and we want to make sure that when we access bar with an invalid index, here we pass it 99. We want to make sure that an exception, maybe we want an exception to throw, maybe we don't want an exception to throw. It's all sort of how we've chosen to design this class. But writing a test like this, make sure that what your assumptions are about the error condition behavior of your code, your mind is in sync with that. And it also shows to someone else who comes through and tries to understand this code what you, the designer, were thinking when you wrote it. So think about testing both positive conditions and negative conditions, error cases, when you're writing some tests. So yeah, question. Right. So what'll happen here is if an exception gets thrown, by default, that will cause this test to fail. So right here, the expected behavior is that bar at index will just kind of silently fail and return nil if you access at an invalid index. If we, as the designer, wanted some different behavior, like maybe we wanted an exception to get thrown. That's what happens when you have an NS array and you say object at index 99 and it doesn't have 99 objects, it'll throw an exception. If you wanted to verify that, there's another st macro. You can say st, I believe it's stassert throws, and you can ensure that an exception is being thrown. That actually wraps that call in there with an exception handler and sort of verifies that the exception is getting thrown. I know we haven't talked about exceptions a ton here, but you've probably run into them in your code. So in this case, I think a little demo is worth 1,000 words. So let's pop into Xcode. And I've got a little project lined up. And I'm not going to write a ton of code in front of you, but I just want to show you how this all kind of fits together. So here we've got this Xcode project. And it doesn't really do anything, but it's got this person class. You all probably had a person class of some sort in your presence project. And this person class has just a single string property, super simple, just for demo purposes. It's got a display name, and that display name is synthesized. So to go along with that, in Xcode, I've created a little group called tests, and it's got a couple files here, person tests. So as I mentioned before, I create a send test case subclass, and inside here, I've got a couple of tests, similar to the ones I was showing you before on the slide. So we say test create person, we create this person object, and we make sure that it's not nil. Test set display name, we get this string, we create a person, we set the display name, and then we make sure that the display name was what we had expected. So if and you can pick apart this project to kind of see what's going on here, but you'll notice I've got 2 targets. In most of your projects, you've just had one target. But I've got the regular application target, and I've got this unit tests target. And if you actually look in the list of targets, what we're doing here is we had this unit test target, and one of its dependencies is the application target. And what this means is you can just have the unit tests target selected, and it'll cause the application target to get built every time it needs to be built. So you can make changes to your application, run the test, and the test will build the app and then run the tests. Does that make sense? Okay. So I've got these tests. Hopefully they all just pass right now. And if I build in Xcode, it succeeds because I don't have any test failures. So let's create a failure. Let's maybe rather than synthesizing display name, let's say we decided to be really, really clever. Actually, we can synthesize it and then add our own implementation of the setter. So set display name, takes an NS string. I know what that is. Thank you, autocomplete. And let's say we did a bunch of stuff in here, but for some reason we forgot to actually set the instance variable, right? So this setter method is broken. So I made some changes. I thought I was really clever. I moved some code around, and I forgot to paste in this last line of code. That's never happened to any of you, of course. And then I build, and hey, there's a build failure. Did I leave out a semicolon or something? No. It says person test set display name, Paul should be equal to null, or actually, yeah, null should be equal to Paul, who knows. Anyway, this failure results in a big, loud warning. You'll notice in Xcode, I've got the little the badge for the number of build failures. So that sort of alerts me that I may have done something kind of stupid in my coding. Another quick and dirty test that you can write to just make sure that the unit tests are running, and I typically write this test every time I set up some a testing rig for an app, just to make sure that it's all sort of in place. You can just fail. There's this stfail method. You can pass it a little, you messed up. And if I build and run here, or yeah, just build here, it'll tell me that I messed up. And it actually goes in line, which is pretty handy. So you can see where exactly the failure was. If you're curious about those st macros, and then I build again, it succeeded, yay. If I command double click on stassert not nil, I believe, no, that's not what I wanted. I want the macro definition. So here's all these assertion macros. I can make sure that something's nil. I can make sure that it's not nil. I can make sure that something is returning true or false. Equal objects, which we'll call is equal. Stassert equals without the objects on the end. We'll just check. It'll be like a double equals check. You can do equals with accuracy if you're comparing floating points that may not be exactly the same. You can make sure that in a certain case an exception gets thrown, making sure that an exception doesn't get thrown. You can just straight up fail, which is what I was doing before. Yeah, so there's all these little macros, and you can write your own, of course. And yeah, pretty handy stuff. Any questions about this before we keep going? So these are the sort of bare basics of setting up unit testing for an Xcode project. Yeah. So the question is, rather than having a separate build target, the unit test target, which is dependent on the app target, is there a way to run the tests as part of the application target? There probably is. I would guess that probably the reason why most people don't do that is because there are cases where you want to build and run without going through the unit tests. So, I mean, because of that, it can be handy to have two separate targets. That is a good question. I'm not entirely sure what the answer is. Really what this unit test target is, my test cases as well as the actual person class live in this target. And it's got a script at the end of it. It's basically just running a shell script, which actually kicks off the unit tests. I suppose you could fold some of that into your main application target, but it can be nice to have them kept separate. Yeah. No. The question was by just defining the test case classes, does it automatically create the target? Unfortunately not. There are some hoops you need to jump through in Xcode to get the target set up. There are some tutorials out there, both for doing this for the Mac and for the iPhone. Unfortunately, it's not just like a single click, give me tests for my project sort of thing. So what you may want to do is, in a couple days when this project is posted online, go in there, kind of pick apart the Xcode project, see what's going on in there, because I would say that it's unfortunately non-trivial to get set up. So yeah, the code will be yours to fool around with. So that was the demo. It's good to think about when unit testing makes sense, when it doesn't make sense, because there's a return on investment here. You're spending time writing the tests, maintaining the tests, keeping them up to date with your code. So always sort of be weighing in your mind the benefit of the test versus the time that you're spending on it. And as I mentioned before, some types of code are not really well suited to unit testing. Maybe they're well suited to some other sort of testing, but they don't fit well with the sort of run every time you build, super quick, not a lot of external dependencies frame of mind. Networking code, databases, although it's often possible to test a sort of subset of your behavior relating to these things and still get some benefit. So maybe you don't want to test an actual live database, but maybe there are some aspects of your database wrapper that you can test without having a real database up and running. So kind of think about that. Maybe slice things apart and test small sections. Unit testing philosophy, just keep tests short, lightweight, fast. Think about testing individual methods rather than end-to-end behavior. That sort of testing can be useful as well, but it doesn't really fit under the unit testing umbrella. One really useful thing, when you find a bug, write a new test that isolates that bug. So you find a bug, you write a test that fails because of that bug. So then when you go and fix the bug, you can have some reassurance that you have actually fixed it. And this has been a huge key for me. I do some work on the UIKit framework, and we get a report in from a developer saying, hey, this thing is broken. And if possible, not every time, but a lot of the time, when I'm not feeling super lazy, I go in there and I write a test. And I call the test, test, that this particular bug report number is actually fixed. And I go in and I write the test and then I fix the bug. And that way, hopefully, I don't accidentally unfix the bug later because of some unrelated change. And really, unit tests complement rather than replace other types of tests. There's a good blog post here from one of the developers of Core Data, where they used unit testing extensively on Core Data, and he talks about some of the benefits, some of the places where maybe unit testing doesn't make sense, and tries to wrap up some of the religious fervor around all this stuff. So that's unit testing. And now we're going to go off into the weeds a little bit and talk about Objective-C. You might be wondering, when we were looking back there, I can just add a new test and call it test something, and that automatically gets picked up and run by this unit testing rig. You may have seen some other testing frameworks. Has anyone done any unit testing with C++? One person? So correct me if I'm wrong, with C++ unit testing, you have to actually list out someplace else in the code all of the tests that you want to have run, right? So with Objective-C, you don't need to do that. And I'm going to explain how that works, as well as some other kind of stupid pet tricks. So if you look on your computer in /user include objc, you'll see some headers, and they define a lot of things that are really fundamental to Objective-C. Things like ID, which is a sort of NS object, which is basically a void star, but for Objective-C objects. Things like nil, both the uppercase and the lowercase variant. Uppercase is for a nil class. Lowercase is for a nil object. Bool, yes, no, all that good stuff. Objc/message.h is where Objective-C message dispatch is defined. So the actual process of sending a message to an object, all of the functions related to that live in there. And then there's Objc/runtime.h, which is where you can inspect and manipulate classes, protocols, methods, instance variables, all sorts of stuff about Objective-C classes and objects. And one really kind of killer thing in here, and you can interpret killer and either way, is you can add and replace methods at runtime. You may have seen this in some places. We didn't speak too much about categories this quarter, but categories are a quick and easy way to add new methods to a class. And categories work via these low-level functions. So first, let's take a look at inspecting methods, what OCUnit is doing under the hood here. A couple things, just examples. You can copy all of the methods for a class. This is something that's dynamically maintained. It's not a compile time thing. It's a runtime thing. So I can, given a class, I can get the list of methods back from it. And then given a method, I can do things like get the name. I can get a pointer to the implementation, which is basically ends up being a C function. I can get the return type, all sorts of other interesting properties of a method. So that's kind of cool. You can introspect all sorts of things about the runtime. So let's check out a quick demo here. And again, this will be posted on the course website. So here we've got obc playground.xcode project. I'm going to fire this thing up. And inside my application delegate, this app, it's a pretty weak iPhone app because you'll see when I build and run here, it doesn't actually do anything. It's just a white screen. But there's actually some interesting stuff being printed in the console. So if you look here, an application did finish launching. There's a couple methods. And the first one that we're going to look at is called print all colors. And what this method does is it looks at the UI color class, which you've probably dealt with in CS193P, and it's going to get all of the methods that have color in their name and return them. So let's scroll up here a little bit. Here's print all colors. And as you can see here, we're going to get all of the class methods for UI color because UI color, if we look here in the header, it's got instance methods, set fill, set stroke. These methods act on a single color. It's also got these class methods where you can sort of get an instance really quickly of the purple color or the orange color or magenta color. So these are the ones that we want to look at. So they begin with a plus. That means they're class methods. So I'm going to say class copy method list from the UI color class. And I get the count back as well in an integer. And then for each of those methods, I step through. I get the name, and that returns a cell selector, which I can then turn into, I can just cast it as a char star and turn that into an NS string. So now I've got this method name string, ASCII encoding. So I've got the string. I just want to check whether it has the suffix color. This is a straight up NS string method. At this point, I'm in happy Objective-C land. If it has the suffix color, then I want to check the return type. And if it returns an object, these are kind of heuristics to maybe guess at what this method does. So basically what we end up with here is we're going to end up logging every method that ends in the word color that returns an object. So there might be some false positives in here. Maybe there's some UI color method which is like, is this actually a color? Or no, that'll probably return a bool. Some method which doesn't actually return a color, but we don't necessarily know at this point, whether it returns a UI color object. So I've got this bit of code, and when I build and run, if we check back here in the run log, you'll see all these colors got printed out. We've got the colors that you know and love from the UI color header, not blue, but red, clear, gray, white, all those Stanford t-shirt colors. And you'll notice there's other methods which aren't defined in the public header. Things like, pinstripe color, underpage background color with names that you would never see in Cocoa Touch documentation. And you'll notice here there's actually this Stanford color, kind of weird. So that is from, and I was mentioning categories before. This is an example of a category. I declare at interface UI color. I use the class name and then the category name. and I've defined that I'm going to add this new method to UI color called Stanford color. And then in the implementation, in the Stanford color method, it's mostly red. I guess it's just kind of a dark red. Cardinal perhaps. So by implementing this category in here, that method gets added to the UI color list of methods, and it gets returned when I'm kind of iterating through here and looking at all the methods on UI color. So that's kind of cool. Let's pop back to the slides. That was inspecting methods and a little bit of adding methods too. Yeah. Yes. The question was, is that one way to pollute the namespace and overwrite stuff? And yes, that is an issue with categories, because you may be implementing a category and maybe you're using some open source code where they've implemented a category method that has the same name. And sort of non-deterministically, one of those methods will end up getting called, and maybe the other one wasn't really expecting that. So a good idea with categories is to add some sort of a prefix to the beginning, maybe unique to your project, to really ensure that you're not going to be polluting the namespace. The other problem is, let's say we have a category here, which adds the Stanford color class, or the Stanford color method. And then in the next release of the iPhone, some mischievous Stanford grad working at Apple has added a Stanford color method to UI color, the actual UI kit implementation of UI color. And again, you're going to end up with a collision. You're not sure which one is going to get called, and maybe a bunch of t-shirts are going to end up in the wrong color, like that one. So that's a potential danger. I'm going to talk about it a little more in a bit. Yeah. The question is, when you're designing your class, is there a way to prevent other people from messing with it? And the answer is no. That's sort of the power and the danger of the Objective-C runtime. I used to have a slide in here. I removed it because I didn't want to be violating Spider-Man copyrights on iTunes U, but with great power comes great responsibility. So you're playing with fire a little bit. Speaking of which, playing with fire. So you can add a new method to a class. And we did this earlier via the category, the category syntax, which is very, it's Objective-C. You just throw it in there. Under the hood, categories are actually calling class_add method to add a new method to a class. You can also replace the implementation of a method. So I can, given some method, I can swap out the actual body of the method. This is where the difference between methods and selectors and messages sort of, you got to know what you're talking about here. So I can replace the implementation of a method. And I can even do this thing where I take two methods and I swap their implementations. And I'll explain. I know, just bear with me here. Again, early in the quarter, I alluded to this as sort of like talking to your kids about, sex, drugs, whatever. It's, rather than hear it from you than from some guy on the street or on a web developer forum. So, right, okay. So method swizzling, friend or foe. What if you want to override a method in a category? You want to add a category on UI color to maybe tweak the implementation of some existing method, say red color. But you also want to call through to the super method. But at this point, you're not in a subclass. You're actually within UI color. So if you were to call super red color, that's not going to work. So what you need to do is, you can't call super because a category isn't a subclass. You can define a new method, swizzle it into place, and then call the old method. And here's I'm really trying to drive this home. But let's say you've got some existing method, and you get the actual method structure from those Objective-C runtime functions. And we've got this fancy new method. And what we want is anytime somebody calls the existing method, we want it to go through fancy new method, call up to existing method as well, maybe to get some existing behavior, and then return. So what I'll do here is I'll exchange the implementations of existing method and fancy new method. And then within fancy new method, this is the crux of swizzling here. Assuming I want to get the old behavior and then add my new behavior, within fancy new method, I'm going to call self fancy new method. Seems like it might cause an infinite loop, but actually what it'll do once the swizzling has taken place up here, exchange implementations, calling fancy new method will actually be calling existing method. And calling existing method calls fancy new method. So anytime somebody calls existing method, it'll go through here, it'll call the old one, and then we can do our additional whatever we're doing. right? Does this kind of make sense? It's a little bit of a, wrapping your head around the, what's that thing called with just one side? Mobius strip, yeah, I don't know. So let's check out a quick little demo here. This was a really fun demo to write, but I sure wouldn't want to have to actually maintain a project that had some of this. So we're going to call this method called Swizzle string methods. And the goal here is that anytime somebody calls uppercase string, it's going to add a little bit of text to the beginning and the end. So elsewhere, somebody has some existing code which calls uppercase string. They're going to get some new behavior, even though they weren't expecting it. So in Swizzle string methods, first, let me show you the implementation of this new method called a counterpart to uppercase string, which is obnoxious string. Actually, well, let's look at this part first. So we get the instance method for uppercase string. We call class get instance method, and a string class selector uppercase string, and we're going to get the obnoxious string method again from the NSString class, and we're going to exchange those two implementations. At this point, let's look up at the obnoxious string implementation. So this is another category. So within obnoxious string, we're first going to call self-obnoxious string. And because it's already been swizzled, this will use the implementation of uppercase string. So now we've got an uppercase string. Whatever we passed in, it's in all caps. And now what we're going to do, we're going to append to the beginning of the string, LOL, and at the end of the string, a little bit of excited punctuation, and return that string. So the key here, this thing, it looks like an infinite loop, but because the method swizzling has already taken place, it'll call the other implementation. So now, if I get some string here, hello world, and I call uppercase string on it, or I take I can take a string literal. This could get really annoying, and I call uppercase string on it. Let's see what happens. If I build and run, go back to my console where all my NS logs go, I get this interesting new behavior on uppercase string. Yeah, think what you will about that. So let's talk a little bit about the implications of this. There are actually some cases where it's useful. I should first say there are some bits of system frameworks. I believe Core Data actually uses swizzling for some good reasons. The key value observing stuff, actually that's using ISA swizzling, which is another, a whole other thing. There are cases where this can be useful, and it's valid to do if you own all of the code that we're talking about. You wrote some code, and maybe you're doing some swizzling on that. But if it gets really dangerous if it's code that you didn't write. So the tricky bit is that other code may be dependent on the original implementation. And if you change it, that can cause unexpected behavior. It can cause bugs. It can cause crashes. Not coincidentally, this has caused some very popular apps to not work so well on iPhone OS 3.0 because they decided to do some method swizzling on internal, non-public UIKit class methods. You can only imagine how that went. So writing clever code, it's fun until you have to debug it. Always keep that in mind. There's going to be a cost paid down the road by someone, maybe you, maybe some poor unfortunate soul. I would say the rule here really is never ship an app that swizzles methods on system classes. If you're writing some app and you're like, man, I really have to swap out the implementation of this UIKit class method for my own thing because I really know what I'm doing, trust me, I would strongly urge you to not do so. Pretty please. But it's still pretty cool. If you want to read more about this, the Objective-C 2.0 runtime reference talks about this and more. It's sort of a good counterpart to those obj.c/runtime.h headers. One last topic along these lines is this tool called ClassDump. And you can give it an Objective-C, you can give it an application binary, and it'll print out to you information about all the classes and methods within that binary. So you can give it an application, a Mac OS X application or an iPhone app, and it'll tell you about the classes and methods inside it. And it's really fascinating to see how a complex application is built. Back when I was a senior at Stanford, my CS194 project was a Cocoa mail application. And I thought, hey, it'd be kind of cool to check out how macOS 10, like the real mail.app is built. So I ran class dump on it, and I checked it out. And there were all these classes and all these methods, and I was like, wow, I really bit off more than I can chew for this final project. But it's interesting to see how other people's design decisions turn into real code, and sort of, it's like paleontology or something. And as usual, this can be used for evil as well. You can run class dump on something like the UIKit framework and find all of the private methods that weren't exposed in the documentation or in the header. Yeah, that can be really dangerous. So there are some prominent folks in the iPhone dev community who said, calling unpublished APIs, it's like jaywalking. Everyone does it all the time. I would agree. It's a lot like jaywalking across 7 lanes of traffic going way above the speed limit. So the problem with using private API, I'm going to put on my Apple hat here for a little bit. Framework APIs, stuff in UIKit, maybe there's a method on UI color that isn't public for some reason. It's probably being kept private for one of 2 reasons. One is that it's not done yet. It's something that's in progress. Maybe it has bugs. Maybe the system apps know how to work around the bugs, but we're not prepared to expose it to you. The other reason is that it may never become public, and it may actually go away. Maybe it's only a temporary placeholder, and this method or this class is not going to be around for long. The nice thing about working internally, when you have control over both the frameworks and the system apps, if you need to remove some class entirely, you can go through all the source code for all of the system apps and remove it all. But you can't go out to third-party apps and say, hey guys, this little class that we added that was kind of a mistake, it's going away, stop using it. It's not really possible with third-party apps. So it's not just because we're evil and we want to keep all the good stuff away from you. If your app depends on private API that then goes away or changes, at best, your app will not work quite as you expected it. And at worst, your app it'll crash. It'll be really an unpleasant behavior for your user. So keep that in mind. Another sort of interesting, occasionally useful tool, but if you abuse it, you might have a bunch of angry users giving your app 1 star in the App Store because it's totally broken. So that's all that stuff. Now, on a more positive, perhaps, note, I want to talk about getting your app in the hands of people all over the world, expanding the possible audience for your application. Yeah, sure. So the question is there a way to obfuscate the output of something like class dump? Now, the tricky thing here is that, you think about some of the methods on Objective-C. There's, does respond to selector. A lot of this stuff is just looking things up by names, right? So, if that were somehow obfuscated by default, a lot of code wouldn't work because it needs to refer to classes by selector name, that sort of stuff. Now, if you wanted to, you could potentially, have some script which, given your source files before it actually builds them, maybe it runs through and it obfuscates all the names. It scrambles them up, however you want to do it. The problem then is that you're running the debugger and you set a breakpoint. It says, okay, you're in method. You probably need to use such a tool with care. And for things like registration codes, serial numbers, you'll probably, I think probably the most common approach to that is that developers, they'll name the really crucial registration serial number method something totally unrelated and innocuous that hopefully is of no interest to a hacker who's using class dump. Yeah, I think that's probably the most common approach is just try to be clever in your naming. So does that answer your question? Okay. Localization. So getting your app across the world in iTunes application stores from Australia to New Zealand. I guess those aren't really very far apart. But so your international iPhone app. How does this work? A big key here is that you don't need to build a bunch of different apps for every different country around the world. You can have a single built application that supports multiple languages and locales. And that way, you've got this app on your phone. You can, your user can switch their language from French to Japanese and launch your app, and it'll be in Japanese instead of French. The way this works is that you keep localized resources, things like strings, maybe images, separate from everything else. User interfaces as well. Nibs are localizable. So what this actually looks like in your app, a lot of the time you've seen nibs and other resources at the top level of your application bundle, going back to the whole what's in an application thing. But if you want, you can have these LProj, I guess it stands for localized project, for different languages, English, Japanese, and each one has its own set of resources, things like strings or nibs. And the correct resources will be selected based on your user's language and locale. So there are really two steps here. The first one is internationalization, or I18N, which is preparing your app to be used in different languages, like coding it in such a way that later you can drop in some different strings, different images, and it works. So being flexible in how you write your code. The other step is localization. These are very long words which are used a lot, so people abbreviate them, L10N, which is actually the process of adding localized data to your app. So typically, internationalization is done by you, the app developer. And localization is something that you can then hand off to someone who maybe is not even a software engineer, but they happen to speak both English and French or Japanese, and they can translate or convert some of the resources in your LProj directory to be good to go on that language. So that's kind of how that works. NSString is worth calling out here. NSString interconverts between a ton of different encodings, so you don't really have to care whether some data you're getting is in shiftgis or UTF-8 or I can't even remember all these different formats. There are a lot of different formats for storing text. NSString most of the time just helps you to not have to think about that. So you can, let's say you've got some data off the web and you want to turn it into in a string. What you can do is pass along the string encoding, typically with something like Twitter or Flickr APIs. They document and they say, hey, all of our data is going to come down in UTF-8. So you pass along that expected encoding. There are also some ways, I believe, to have it sort of guess if you're not sure what the encoding is. But NSString is really, really useful, so you don't have to think about encodings in your iPhone app. Let's talk about localized strings. So for any bit of text that might appear to your user in the app, like an alert dialog that pops up when some error occurs, you're going to want to be thinking about localized strings. And what you do here is basically within your code, maybe when you're creating that UI alert view, you're going to map from an unlocalized key, which you as the developer, you can read it. It says, maybe hello. You map from that to the localized display string, bonjour or konnichiwa. And those mappings get stored in strings files. Please excuse my horrible pronunciation. And these strings files are in UTF-16, just so you know. And so what this actually looks like, maybe we've got a strings file, and it contains the greetings that we have in our application. I don't know what the app does, but it's doing greetings for some reason. So you'll see, in English, because as a developer, I'm working in English, probably the keys that I'm using, just so that I can easily, so that as I'm looking through the code, I know which localized string I'm referring to. Typically, those ones will match. So hello, hello. Maybe we've got a format string to be used with NSString. So welcome to blank, welcome to blank. Maybe we've got one that has two parameters, blah, blank, blah, blank. And then in French, in the strings file, so you typically take your English strings file, you hand it off to your helpful coworker who speaks French, and they fill in the correct values on the right side for the values here. So hello gets translated, bienvenue, it gets the little, it still has the format argument in there. And let's say that for some reason in this language, blah, blah, whatever, those two arguments need to be in the reverse order. There are a lot of cases in languages where, in English, you've got adjective, adjective verb or adjective noun. And maybe in another language it's noun adjective, stuff like that. Ordering sometimes matters. And you can do this. You can specify arguments by order by throwing in a numeral and a $sign, and that'll basically take the second format string argument and then the first format string argument and populate them in there. It's kind of a bit of trivia. You probably doesn't really matter to you right now. So that's what a strings file looks like. You've built up that strings file. And then in your code, when you need to use one of these strings, there are a couple of handy functions which you can call. NSLocalizeString is one of them. So you pass the key, and you pass a sort of default, the second argument is just a description of what that string is, which you can refer to in your code. You can also specify the table. So you notice back in the previous slide, all those strings were in this greetings.strings file. is you can specify, you can have multiple strings files and kind of make it more manageable if you've got a lot of localized resources. Break them up. There's this tool called genstrings, which you can use to scan your code and produce a strings file based on all of the strings that you've got in the code. It inserts the comments found in the code, the whole greeting for a welcome string. It inserts that into the .strings file as a clue to the localizer, which can be kind of helpful. So you run this tool over your .m files, and it returns a .strings file to you. Other types of resources, all the NS bundle methods, when you say like, image named whatever, or path for resource with name, all those sort of NS bundle or UI image methods, those automatically look in the right directory for your user's language and locale. So you don't really have to think about it when you're grabbing an image from disk and popping it into an image view or something like that. Nib loading does the same. So you start with your English nib, you pass it off to the localizers, they update the button titles, you throw the localized nibs into the localized lproj files, and the correct one gets loaded up. As far as internationalizing nibs go, plan for different string lengths in different languages. German is a really, oftentimes there'll be some little bit of text, and it's this tiny little button in the corner, and it says, OK in English, and it turns out in German it's 20 characters long. So yeah, it's a great sort of cultural exchange opportunity to think a little bit more flexibly about how your UI might need to be laid out. So how do you take an unlocalized resource, say a nib or an image, and turn it into a localizable thing? Here we go in Xcode. We hit Command I. We got info on some resource, our main window.zib. And there's this make file localizable button in the lower left. And if we click that, then what will happen is actually in Xcode, our main window.zib, it'll expand out, and there will be actually 2 files within it that we can select. And we can add additional localizations in there. So that's sort of what it looks like when you're browsing a localized resource in Xcode. Last thing I want to mention, there's this handy class called nslocale, which encapsulates a lot of the interesting, worthwhile things to know about locales as you're writing code for doing things like formatting currency, numbers, dates, country information, measurements, all that sort of stuff is in there, and it's a good class to rely on if you're doing anything like that in your application. You can automatically pick the right types of units or currency symbols, all that sort of stuff. So good to think about. Many apps don't need any of that, so they don't care, but it's there if you need it. So that's localization and internationalization. I know we're covering a lot of stuff today. It's the last lecture. Just so much stuff that we wanted to cover. The last thing, we get letters here at CS193P. We get emails. We get Twitters. We get instant messages from time to time. And I wanted to take a little opportunity to open up the mailbag and answer some questions, some frequently asked questions that we've been getting from folks in the course and out on iTunes U. This is actually our mailbag, our inbox. I'm so proud of that transition. First question, how do I launch my app in landscape orientation? Maybe you've got a game, maybe you've got some app which is just really designed for landscape, and you want this thing to come up in landscape by default when you first launch it. How do you do that? There are 2 steps here. The first one is to specify the initial interface orientation in your info.p list. This is the property list that describes a lot of the basic things about your app, like the main nib and all sorts of other stuff. This is a clipped view of the info.p list. But one thing that you can specify in there, you have to add it, it's not in there by default, is the initial interface orientation. You can choose portrait, landscape left, landscape right, upside down, who knows. So you specify that initial orientation. The second step is to support the specified interface orientation in your view controller. Does anyone remember how to do that? What's the method you override?
You say return yes.
You return yes.
It's like support auto-rotation.
Should auto-rotate to interface orientation. Yeah, it's kind of a mouthful. Override should auto-rotate, I can't even say it, to interface orientation. And you return yes for the orientations that you support. So assuming your root view controller, or whichever one is displaying on launch, supports the initial interface orientation, then your app should, if all goes well, just launch in that orientation. Note this works on iPhone OS 2.1 or later. There was a bug on 2.0 where this didn't work quite correctly, but for what it's worth, I think most people are up on the latest iPhone OS release 2.2. I'm not going to quote any numbers here, but the update rate is really, 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 really high. So here's what this app looks like when it launches. It's got, it's utilizing the full width of the screen. So let's take just a quick little look here at this sample project. And this will be on the course website. So the first thing, here it's called landscape-info.plist. You get one of these by default every time you create a new project. And in our property list, we've got all this stuff, the version and the bundle identifier, com.yourcompany.whatever. You can specify the icon, the display name, and here I've added, actually, let's just add it ourselves. I'm gonna hit return here, and it'll show me a lot of the options that I can choose from. And one of them, as I mentioned, is the, where is it? Initial, what was that thing called again? Initial interface orientation. I don't know why that's not showing up. Well, at any rate, here's what it actually ends up being in your property list. So the key is UI interface orientation. The value is UI interface orientation, landscape right. Here we want it to launch in landscape right. And if we look at the view controller, we've made sure to return, here we don't care. We support all orientations, we just return yes. So if I then build and run here, nope, can't launch in simulator while it's already in use. Goodbye, Objective-C Playground. Goodbye, test my app as well. Oh. Build and run. And you'll see the simulator comes up with the status bar in landscape to match the initial orientation. And the app is in landscape as well. Now notice we returned yes here for all orientations. So if we rotate to portrait, it's going to rotate to portrait, and I haven't set up my springs, my struts, anything to resize here. So you either need to make your application adjust gracefully when you rotate, or what you might do is just return UI interface orientation is landscape. So only return yes if it's a landscape orientation. So what will happen there, if we rotate, it won't do anything. If we rotate to the other landscape orientation, it'll flip over to the correct one. Yeah, so that's a landscape or an app that starts in landscape. There's that again, just in case you didn't see it the first time. And that code will be on the website. The next question we've gotten from a few folks is how do I customize UIKit views and controls? When is it okay to customize things? When is it not? What are the right things to do here if I want to have some custom art or custom behavior on views and controls? So I think it's maybe useful to think of classes in three categories. There are some classes that are really designed to be customized, to your, heart's content, more or less totally customizable. So UI button, you can specify a custom background image. You can put whatever you want in that background image. You can have different images based on whether it's up or pressed or whatever. UI table view is another one where you can really, you specify the cells. You can specify the header views, the footer views, custom images for the section headers, section footers. You've probably seen some apps on the iPhone that are using table views without any of the stock table view art. So these classes are really designed to have their appearance customized in all sorts of ways by you. Other classes have limited customizability. Classes like UI slider, where you can customize the image on the left, the image on the right, some of the art in the middle. It's not fully customizable, but you can get in there and mess with most things. UI navigation bar. You can customize the translucency. You can customize the tint, the color. You can give it a black or default bar style. But there are a lot of things that you can't customize about that, and we're going to talk about that a little bit more. But really, UI navigation bar, the particular subclasses of it are not documented at all, and there are a lot of things that you can't just go in and give your nav bar a totally different look. And then finally, there are some classes that are really not customizable at all. UI switch, UI tab bar, these don't expose properties or methods for customizing their appearance or behavior. For cases like these at the bottom, you're always free to implement your own UI view subclass or UI control subclass, do your own touch handling, do your own custom drawing. So really, when you're figuring out what's safe to customize, look for methods in the class header or in the documentation for customizing the appearance. So UI button, background image, UI navigation bar, as I mentioned, UI table view. There are delegate methods, and there are properties on the table view that you can customize. And then if you've got some custom control and you're trying to decide, should I subclass UI switch and try to override a bunch of stuff, or just create my own UI control, sometimes creating your own UI control subclass is the right way to go. It's worth mentioning here, the idea of respecting the view hierarchy. When you've got UI kit classes like navigation bar, or the views of navigation and tab bar controllers, or the image picker controller, these classes don't document what their subviews are. They don't make any guarantees. So making assumptions about what's in these classes is pretty unsafe, and it'll likely break your app in the future. That happened to a lot of apps that tried to customize the camera view on the phone by just walking up super view, grabbing the subviews array. The object at index 3 happens to be something that I want to customize. I'm going to move it around and add some stuff to it. And then later, when the implementation changes, you're kind of left out in the cold. So really, it's important to not manipulate undocumented subviews of system views. If it's documented, great. Otherwise, you're treading on dangerous ground. And don't add your own custom subviews as well. If you add some custom subview to UI navigation bar, you don't necessarily know how it's doing all of its drawing. It's got a lot of subviews. It's transitioning them around. They're flying all over the place. They're layered in a very particular order. And if you throw an extra view in there, it's probably not going to display correctly. You want your application to work well in the future on iPhone OS releases 4, 5, 6, whatever. Next question. Should I create my views using Interface Builder or in code? This is an oft-asked question. I would almost always recommend that you use Interface Builder, really, especially when you're creating a view that's got a bunch of subviews. It's a container view, and it's composed of a whole lot of different things that need absolute positioning. They maybe need to be aligned and centered. You're going to be writing a lot of code to deal with this programmatically. The one case where it's not as useful is if you've just got a single view, a single more or less opaque view, like a table view, where let's say you've got a view controller, and that view controller is managing a table view, and you're determining the appearance of that table view in code via the data source and delegate methods. Here, there's not a huge win to using Interface Builder. So that would be the one case where I probably wouldn't use IB. And then, as always, remember, the sort of rule of thumb here is that for every view controller, that view controller owns a nib. That view controller is files owner, actually. You make connections between the view controller and the stuff in the nib via the files owner proxy. I would kind of keep that in mind as you're putting an app together and thinking about IB. A couple of thoughts on nibs and memory management. If you'll recall, top-level nib objects are auto-released when you load a nib. So here's our nib, or our zib actually. And everything to the right of first responder, these objects, when you load the nib, they will be auto-released. And if you want them to stick around, you need to retain them either, and the most common way to do this is via an IB outlet. The other thing worth mentioning is that IB outlets, once you've created them, they're retained by default. Even if you haven't implemented a setter method, either via synthesize or actually writing a setter, if you haven't implemented a setter, these things will be retained, and you need to release them in dialog, even if you don't have a setter. If you don't want objects to be retained in IB outlets, you can implement or synthesize your own setter, which uses assign rather than retain or copy. Does that make sense?
Where would you retain them?
Where would you retain them? You would retain them in the files owner. Or actually, in this case, what's going on, sorry, I probably shouldn't have circled the app delegate here because the app delegate, I believe, is being retained elsewhere automatically in the UIKit sort of machinery. So typically what's going on here, this is your main window.zib, and this sort of goes along with your application delegate class. Within your app delegate, the app delegate probably has outlets to the window and some other object and the view. So probably here what's going on is this guy is retaining these three. Typically you've got a property for the window in your application template. Yeah, if this was a view controller nib, then the view controller is represented by the files owner, and typically the files owner, the view controller would be referencing whatever top-level objects there are in the nib. It's rare to have a whole bunch of top-level objects in the nib. I threw that some controller and some view in there just so I would have some extra things to circle in the illustration. Most often it's just a view and the files owner or something like that. Next question, where can I get cool icons for my toolbar or tab bar items? I was just discussing this with someone before class and last class. It's especially as you're putting your final project together, people want to have some good-looking art in there and not just like their little. I've made toolbar icons before in image editors, and they're really horrible. So it's nice to have a professional artist to work with. Some quick notes about what these images should be. They should be around usually 30 by 30 pixels, and it's a PNG with an alpha channel. And the colors in these images are totally ignored. UIKit just looks at the alpha to create a mask, and then it uses the correct colors, whether it's a tab bar item or a selected tab bar item or a toolbar item. So that's what these images should be composed of. There are some great free icons out there. If you go to glyphish.com, these are some images by Joseph Wayne. I'm actually using some of these in my WWDC presentation next week with Joseph's blessing. These things are Creative Commons license, which means you can use them, you can remix them, you can share them as long as you attribute the author, which I'm doing right now. Here are a few of them. You might find some of them useful in your application if you're writing a shopping cart app or a Skull and Bones pirate app or whatever else. So pretty cool. Check them out. There's the link. Is this the last question? I think this is the last question. Can I build Mac apps now that I know iPhone development? I don't know if a ton of people have asked us this, but it's a good opportunity to plug another class, which some Apple employees teach. At this point, you're done with the quarter. You're familiar with Objective-C. You know Objective-C. You probably didn't before. You know the Cocoa Touch frameworks, UIKit, Foundation, all that stuff. You're all comfortable with object-oriented design patterns. You know Interface Builder, Nibs, Xcode, all this stuff. Developing for the Mac desktop is within your reach. I mean, a lot of this stuff is really similar. The first few lectures of this course and CS193E, which is our desktop Mac Cocoa programming course, are identical. We just reuse the lectures. It's like, here's Objective-C, here's all the sort of basics of drawing. So the big difference is Cocoa versus Cocoa Touch, and specifically UIKit versus AppKit. UIKit was created after AppKit. There's a lot of the same types of things. You've got UI window and NS window, UI view, NS view. A lot of classes are very, very similar, if not identical. There are a lot that don't exist on one or the other. So again, I mean, developing for the phone versus developing for the desktop, there are some pretty big differences. So there are things that may not exist on one or the other. Check out cs193e.stanford.edu. Actually, the slides, example code, assignments, all that stuff is still up there from the last time that course was taught. I believe it was the winter of 2008. So you can go up there, check it out, download everything you want, take it the next time it's offered. I think it may be offered next year. I'm not sure. But you are in a great position right now to write Mac apps as well as iPhone apps. So yeah, that's the mailbag. Sorry we didn't have time to get through more. We had some great suggestions for other topics, but time is running short. So course evaluations. Al mentioned this on Monday. We would love to hear your feedback about the course. Info here. I believe it actually, you do the course evaluations on Access, right? And you get your grades early if you do it, so there's some extra incentive for you. Final projects, hope they're going great. They're due on Sunday at midnight. And don't forget to include a few slides, Keynote or PowerPoint, that we will then integrate together into a big old mega deck of slides for the rapid fire presentations on Monday, 12:15 to 3:15 p.m. And if you get a chance, I know you've got a ton of free time at this point in the quarter to just like walk around your dorm room and talk to yourself about your final project. But if you get a chance to just sort of sketch out what you're going to be talking about, rehearsing your 2-minute presentation, you'll end up sounding a lot, like you actually know what you're talking about standing up here. WWDC is next week. Is anyone going to WWDC? One? Okay, well, oh well. Yeah, it should be pretty cool. If anyone out there is watching, come to iPhone View Controller Techniques. I'll be talking about some new iPhone OS 3.0 stuff. It should be really, really, really fun. We're really looking forward to seeing your final projects. It should be a lot of fun. And thank you. It's been a fun quarter. Thank you to everyone at Stanford and Apple and everywhere else. Brent, Jason, Paul Marcos, the TAs, Troy and Paul, Al as well, and everyone else. Thank you.
For more, please visit us at stanford.edu.